You found it. This is where the game gets changed. All right, let's talk through a handful of official SAT problems. These happen to be taken from Practice Test 3, Non-Calc. And I'm going to introduce some strategies, tricks, shortcuts, multiple ways to attack certain problem sets. And maybe you've seen some, maybe you haven't, but it's all in the service of helping you take your scores to the next level. So before we get going, I just want to point out what I see far too often, right? The College Board makes a lot of money, namely by getting students to retake the test because they didn't get the scores they wanted. One of the ways they do that is the strategic implementation of trap answers, right? Or what I call trip before the finish line setups. So in this case, right, if you were doing number 5, you'd find that x equals 10. And the test writers capitalize on the fact that students will solve for 10, they're stoked, they circle it, they move on, right? But the problem's asking for, what do you do when you put it over 5, right? You'll see that in the systems of equations where you'll solve for x, but they want, say, xy, or some variation on that. So be aware, circle, star, whatever your preferred graffiti is, what the problem is actually asking for so you don't lose points at the very end. All right, first, systems of equations problem. Definite heavy hitter. You're going to see system of equations tested in a variety of ways. All right, this is a top, bottom, pretty classic. And as I said above, what do they want? They want x minus y. So if they just wanted x or they just wanted y and it was which of these values satisfies, I would plug in the answers, but they don't. They want x minus y. So one way to do it is get rid of a variable. So if we wanted to get rid of x using elimination, right, we'd multiply this entire line by 3 and multiply that entire line by 2. And then we would rewrite, right? 6x minus y equals, and make sure, again, another way to lose points, signs, which is one reason why I never distribute a negative. I always distribute through a positive, and then I'll show you at the end. Now it's my prerogative to add or subtract to get rid of one of these variables. So in this case, I'm subtracting, stack and subtract, or stack and add. In this case, we're subtracting, and what do we get? We get negative 5y equals, remember, negative 30, so y equals 6. Take that, I don't want 6 though, put that back into here, all right? And you get 2x minus 18 equals negative 14. Bring the 18 over there, and you get 2x equals 4 and x equals 2. Okay, so x minus y is 2 minus 6, and we're done. But is there another approach that we could take? Sure. Here's what it is. When they telegraph this, they want x minus y, or you might see it as they want 3x plus 3i, or 5x minus 5y. If you see a problem that's in this format, there could be a cheat code telling you that what you can do is this: stack these, and then in our case, let's add them, because I don't want a negative because this x here is positive. So 5x minus 5y equals negative 20. Well, that's looking friendly, because I'm going to take out a 5, and I'm feeling good about that decision because I'm done. X minus y is negative 4. Look at how much time we just saved there. And that is the name of the game. We want to use that time. We want to be efficient. All right, another systems. And in this case, a system where the reading comp element is just as important as knowing how to do the math, because you will see this almost on each and every test. Well, they'll show you a system, and they'll be like, for what value of, you pick your favorite letter, will a system have no solution or infinitely many solutions? Have to know the difference. No solution, these bad boys are parallel lines. And what are equal and parallel lines? They're slopes. So you have to extract the slopes, set them equal to one another, and in this case, solve for k. All right, so first rearrange, and this is a skill that you have to have polished, rearranging into y equals mx plus b form, right? I'd move the 3 over, I'd move the 5 over, leave the slopes on the other side, let the 4s go over, let the 7s go over, and basically you're going to have this. Now, I don't care about the y-intercepts at all because it's slopes that I'm concerned with. If it was infinitely many solutions, then I'm concerned about the y-intercepts over here. But for our purposes in this problem, I am only concerned with these. There's my slopes. Let's extract them. Kx over 3, 4x over 5, nice and clean. Cross multiply, another skill that better be on point. If you want to maximize your math score, kx, oops, so it's 5, divide through, and you're going to get rid of the x's, and you're going to get 12 over 5. Done. But I want you to be able to do it faster than that. All right, so you notice, right, you're practicing right away. Your radar should ping. It's a system, it's no solution. These are parallel lines, slopes are equal. You will get so good by practicing that you can rearrange this in your head and you will be able to see, okay, these are going to be positive y's, these are already positive, so the slope's going to be positive. Good test taking always means getting rid of answers that you know aren't lasting. And check out who's playing out in this playground here. 3, 5, and 4. No matter what you do to get the slopes, you're never going to get a 16, and you're done. All right, abra parabola. I'll have an entire episode dedicated to going through a whole slew of parabola problems. But for this one, just really quick review. What's important with parabolas? Vertex form of the equation, and they might show it to you in vertex form, intercept form, a standard form. But in this case, what we want to know from that is basically like that's 11, and we're looking something like this, and then they're telling us y is 25. Notice both y's, and that's AB. Okay, so concept parabola. What do they give us? How do I use it? They give us y equals 25 and y equals x minus 11 squared. Well, what's really important about parabolas is symmetry, right? And excuse my inaccuracy there, but we know that that's 11. And so these are going to be equidistant to either side, to the left and right? And so what are those points? Well, just use the 25 that they give you up there and set it equal to that. But the more you watch me, the more you'll know that one of my methods is to do as little math as possible. So 25 equals, I'm just going to be like 25 equals what squared, right? Two things. What two things equal 25? Well, 5 and negative 5. All right, how do I get that from there? Well, 16 minus 11, that equals 5, and 6 minus 11. So my 2 points here are going to be 6 and 16. And how far are those two things apart? 10. How do? You do it like that. All right, so here they're giving us another parabola, and this is an intercept form, right? You see parabolas given to you with the vertex form of the equation in standard form, all right? And so we could, FOIL this up top and then bring our old friend axis of symmetry, a super helpful get out of jail free card when you're doing parabolas. And go back in a time machine with me, if you will, and retrieve this from your memory banks, all right? Midpoint. And that's what we're going to use here, because they're giving this to us in intercept form, meaning we can just do a quick sketch here. Let's make you -4. Let's make you 2. And our parabola is going to look something like that, okay? So using these two things to get midpoint, you're just going to have -4 plus 2 over 2, giving you -1. Pop it there and pop it there. What do you get? You get -1 minus 2. And you get -1 plus 4, which is -3 times 3. And I'm liking it a lot. D is Y, and you're done. All right? No better feeling than making your way through the math, seeing these common concepts, and knowing that you have a number of ways to attack them. All right, and lastly, what do we have? What are the solutions to that quadratic, which is in standard form? But if you peep the answers, you will see that yes, indeed, there's a chance that we will be dealing with the quadratic formula. Don't be intimidated by these formulas. The SAT often rewards students just for the recognition of them and just like plugging in numbers. So get good. Quadratic formula, equation of a circle, vertex form of the equation, difference of squares, all right? Preparation, separation, go get it. And what I want you to add to that list is this sweet little shortcut, negative b over a, right? Which is the formula for the sum of the solutions to any quadratic. Let's put it to work right away. Negative b over a, negative 12 over 3, that's negative 4. What plus what is negative 4? No, no. Your spidey sense, the more you practice, will tell you b is an iffy answer, but let's prove that. First, let's make our lives easier by simplifying. Always a sweet move. This is A, this is B, this is C. So A is 1, 2A. You're not it. You are. You're done. You're moving on. You've got time. You feel in control, right? That's the operative mode, that you're taking the test and the test isn't taking you. Let's get there together. So until next time, be good and be good at it.